Hello, my name is Georgios Kounis and I'm owner of GN Electronic and Medical Solutions in Greece. I wish to introduce this video to you because I want to answer to some questions of some colleagues from some groups in LinkedIn as concerning the CCTV designing softwares. And as Advanced Robotics partner, I wanted to give a solution to all the people that are asking consultation as concerning what kind of lenses or what kind of um, IP network to use in order to support the bandwidth for all the cameras that they're going to use. There are several questions that in order to be answered, and so the usability of this kind of softwares, and specific the one made from GVSG, is necessary actually, as I believe, to show exactly what is the theory behind whatever we need to calculate in order to ask or select the proper lens or the proper camera for the purposes that they are going to support the final decision in the designing or integration of a system based on the needs of our clients. So let's see some theory behind the basic characteristics of a CCTV system, which CCTV system is the camera. So what we have in a camera is actually a lens and the CMOS, which is the screen, and actually we have the image which we wish to record. So as a first step, we know that there are several cameras and we have to know what we are talking about when we talk about 1/4 inch or 1/3 or one versus sorry for this. We go here. Okay, 1.25, 2.5, or half an inch or an inch. We have different sizes of CMOS as width and height, of course. It's the size of our screen. Most commonly, we have 1/4 of the inch or 1 versus 2.5, which is a common CMOS dimension for some of the robotics cameras. So let's see what else is interesting in a camera. So we have the lens focal length, which is the distance between the screen or the CMOS and the lens, usually measured in millimeters. And then of course we have the lens field of view or the field view angle, which is the phi, and usually it's the horizontal angle or the vertical angle. Here we should talk about the horizontal angle field of view. And when we talk about the field of view, horizontal field of view, we're talking about this area to this area as an angle of view. And the angle of view, of course, has to do with the width of the field of view. So it's the width of the area that we wish to record, and the maximum, of course, and the height of the field of view is the height that we wish to record. Usually the height that we wish to record when we are recording people, it's more or less the height of a common person, like 1.7 meters or 2 meters or something like that, except if we are tracking an area in which we wish to check the size of or the plate of a truck or a car. So in this case the height might be smaller because we have a short phi or angle of view lens in which we have to focus over the plate of the car. And of course we have the maximum distance of the lens of the camera from the field of view, which is the distance in which we wish to see or record the specific scene. The CMOS analysis, of course, is something which is very interesting, especially in the IP cameras. We have the CCD width by the CCD height in pixels. So we know that in the common analog cameras we have the 720, which is the common analysis of the common TV systems, 720 by 23 or 22, if I'm not mistaken. 520 actually. And of course, in most of the cameras, we have higher resolutions like 1 megapixel or 2 megapixel, 6, 12, or whatever we have. And this actually shows the resolution of this CMOS, or actually how many pixels per width or height will be used in order to demonstrate the area that we wish, or the scene that we wish to analyze actually. So there are some specific characteristics like these are not any mathematical types, but we have in small distances we have wide angles, of course, and small focal length. So if the distance is very small, the angle is going to be very high or wide, and the focal length, of course, is going to be small. But as we go in bigger distances, the area or the angle has to be narrower in order to focus in a specific area, and we go to big focal lengths. All these are demonstrated in this kind of mathematical type. So the focal distance of a lens versus the distance from the lens to the scene is equal to the CCD height versus the height of the scene, or the CCD width versus the width of the screen. And from these kind of types, we know that the maximum distance in which we can see something is this it's coming from this mathematical type, which is the focal length multiplied by the width of the scene divided by the CCD width. And of course, the half of the tangential of the field of view angle is equal to the width versus the double of the distance from the scene. So all this, to people that do not know any mathematics, might be very complicated. To some of the people that know some mathematics, there are some mathematical types. So how we're going to use them? In order to start using this kind of mathematical types, we have to understand what is the European prototype 50132-7, which actually says what kind of analysis we need in order to make a specific job with our camera. So we have from this prototype 1, 2, 3, 4, 5, 6 different types of using from the camera. We have the monitor, the detect, the observe, the recognize, the identify, and verify. And in order to actually recognize someone that we know, we need to have 125 pixels per meter of the width of our scene over our camera, as I said before. And from this type, we know that the horizontal analysis of our lens should be the width, as we said, of our scene multiplied by the desired analysis of this kind of analysis. And we can see here the difference between a recognize and just a monitoring or detect, which is actually detect, I would say, which is what we see over here. So these parameters, as I said, can be used in order to determine the maximum distance between the camera and the supervised area, the minimum resolution to match the position of the camera, and actually select the most suitable camera lens. The question is, of course, whether a video image is usable or not, depends on the purpose of the system. So this actually says or give us the information if the camera will have the ability to simply perceive a change in the context of the whole area, or it will be able to use it as a reliable identification of a person that we don't know in order to be used in the code. So let's see in the next slide exactly what is each one of these parameters. So as concerning the monitor, we need to know if we have someone moving inside our scene with direction and speed or something like that. So we need to know if someone is moving inside the area that we try to identify. They are more or less known to the people that use the CCTV. So the detect is allowing someone or an observer to find out with certainty that the person is in a position of the surveillance area. And this one is the observe, which allows the observer to reconstruct the actions of an individual person with almost absolute certainty that is in the position. And then we go to the basic ones, which is the recognize, which allows the observer, of course, to certainly be able to recognize the person that he knows. And the identify, which is more or less the previous, but you can use this in order to identify a person that you might not know. And of course, the last one, which is the most highest level, is the reproduction of data. It's so good that the observer can almost certainly be perfectly identify a person who not only knows in the basis of the video, but also the image was taken in poor contrast or light conditions. So with a hemispherical camera, of course, things are not so certain. So more or less, we introduce three areas where we can have some kind of information from a hemispheric camera. Hemispheric cameras used in order mostly have something like observe, detect, or monitor based on where the camera is, what's the position of the cameras concerning the height. So humans, for example, can be identified in distances of 1.5 meters with sufficient gel at 3 meters. But if we go to distances above 5 meters, we have recognition and we have possibly monitoring if we place the camera even 100 meters above. So things with hemispheric cameras are a bit more strange. We cannot use the lenses as we're using them in the common cameras, and we're going to see for the software. So here I have an example. Okay, so we are looking to have about 5 meters resolution, which is going to provide the recognition at a distance from the camera at 20 meters. And we know that we can use robotics cameras with a CCTV of 1 to 2.5 inches. So we know that the horizontal analysis should be the width of the field by the desired analysis, and we know from the matrices that in order to have recognition we need 125 pixels per meters. So the math says that we need almost 625 pixels, and the most close analysis is 640 by 480 pixels. It's the only analysis that we have. We don't have 625, of course. Then we go to 960. And then we're using one mathematical type that I demonstrated before in order to find the field of view angle. And we do the maths, and we see that we have 14 degrees. So the 14 degrees is not something that we have in our dispose. So we go with a 13 degrees, which is the closest to the 14 degrees that we calculated. So we see from the tables inside the robotics camera support website that if we wish to recognize a person at 21.94 meters, near the 20 meters, we need at least a 64 by 48 with a horizontal angle of 13 degrees. And of course, this is a lens of L160. So if we go more in the calculations, because this specific lens has 5.70 millimeters by 4.28, we do the maths again, and we see that this is a 22.8 millimeters lens in the focal length. And we know that L135 to L160 it's the closest to this one, and it's 23.7 millimeters, which actually is this length, is this lens. So we did all this kind of mathematical tricks anyway to find out which lens we're going to use from this specific camera. Robotics gives specific models in which more or less, if you understand these kind of things, you can find out which lens you are going to use. But what if we wish to have more cameras? What if we wish to calculate the installation height and the field of view of height? What if we work with different cameras? What if we want to demo the camera's field of view for a real surround which was given from a client? What if we wish to demo the EN50132 prototype to show in which areas the person is going to be identified and in which areas he is going to be monitored? What if we wish to calculate the total bandwidth and the total hard disk space based on a scenario of the percentage of movement inside our scene? Or even more, what if we wish to present 3D imaging of the field of view in Google Maps, or create 3D models in order to show how you're going to see someone behind a tree or behind a car or behind a big vehicle that you might have in your scenes? Then maybe what we have here is not necessary adequate, I would say. So we're going to present now the software from the JVSG, which is this one. So we have this one in Greek. It's coming in all kind of languages. So what I'm going to do now is I'm going to change this one to English, okay, in order for all you people to understand what we have in the main screen. And we see that we have two basic menus over here. This is the network bandwidth, which is working after we calculate all the cameras. But for our system, we're going to use this one. I'm not sure if it has been changed. Of course, it has been changed. So we have a 640 by 48 bit PGA image, and here we have the compression. So let's go in this H264 with a good quality, and the image complexity, let's say that it's above average, which means that we have a place, maybe a parking, and the motion could be, well, let's say average. We have a very big store where we have a lot of motion, and the frame per second could be 15 frames per second, let's say, and we need to have 15 days of recording with one camera, and this one is going to be 100%, so we don't have any intervals actually, so we don't send any timetable, so we can go here and remove all the timetables, and we say that the camera is working, let's say 100% all the day, and we have the bandwidth, we have the disk space, we have the bit rate, and we know that in order to do that we have almost 80 gigabytes of a hard disk in order to run the whole day with this kind of frame per seconds for 15 days with one camera. So if we wish to go to 10, of course we reduce the disk space. So it's very easy actually with this kind of software. If we have more cameras here, we're going to see in the next video maybe how it works, to have a rough calculation, if not very precise, of what we need in order to store our data and know what kind of switch we need for the specific area, even if we need to make a specific VLAN or a different network from the network that the client has. So let's go and see some other characteristics. Here, the people that made the video, they have a lot of camera data from various companies with all actually the characteristics. So each and every characteristic from the camera has to do with the manufacturer, the model, the description, the connection, if it is IP or analog, if it is box, bullet, PDZ or whatever. What is the max resolution? So let's go and see if there is any camera. So the max resolution in this one is this. What is the sensor format? As we said, the sensor size, if we need to add it, the aspect ratio, the lens included or not included, if you can change the lens, if the lens is fixed or barrier or zoom or whatever, what is the maximum frame per second, optical zooms, color, day, night, iris, autofocus, a lot of data which we have for each and every camera. And of course, you can add the camera over here, the camera that you're using. So for the time being, we're going to actually not select one of these cameras, but set up a camera of our own, and we're going to select this one because we know that it's a robotics camera. And we're going to make the same example as before and see how simple it is to use this kind of software. So as you remember, I wanted to go to 20 meters. So I wanted to go to 20 meters, and I wanted the width to be 5 meters. So I just go to 5 meters. 5 meters. 5 meters of width. And the height, of course, I just leave it as 2 meters because I want to see the person. And what I have here is 23.49 focal length. And if you remember here, we have in our previous slide, let's go to this slide, 23.7. You remember how we calculated this, and of course you know that it was not so easy. But here we know this is the focal length that we are going to use. Okay? So we wish to know what is this yellow thing over here. Okay? So I'm going over here and ask in the system, in the camera visualization, the prototype EN5033, and I'm going to see what is the yellow. And the yellow is the recognition. We cannot see it here because it's in English, so I'm going to restart the software in order for you to see it in English. So we start the software again, and we're going to see the same example again really quickly in order for you to understand what exactly I'm talking about when I'm talking about the yellowish thing. So the software starts like this. We go to the 1.25, we go to 20 meters, and we go to the width of 5 meters, and we have the yellowish area over here. We have this kind of analysis, so let's go and select something else like a shift, let's say, and we go here and in the side plan, which is another view from above, I'm going to ask the software to give me the zone legend. So the zone legend says that we have what? We have probably an observation or even a detection, which is not what we need for this specific area. So I'm going to start and increase my analysis. We see that we have a greenish area over here, a yellowish area. Actually, it's recognition, it's what we need, but it's not at 5 meters. It's at much less. It's at 4.2. We need to go to 5 meters. So we need to increase more the analysis. So we go here and voila. We know that at 5.2 we have a recognition pattern. We go here, okay, and we have a recognition pattern in the area that we need. 125 pixels, the software shows exactly what is the model, so we don't need to know what is the specific model, and we have recognition, so we know the analysis that we're going to use. We know from the lens, we know exactly what should be the focal length. So if we go to increase the height, we're going to see how things are going to change in the width of field of view. They're not going to change a lot. But anyway, if we go to the opposite way, let's say that we wish actually to have an installation at 4 meters, and we wish to actually have someone the distance which is less, of course, at 10 meters. And at 10 meters we wish to have a field of view of a very wide field of view, let's say. So let's go at 15 meters, and we know that we're not going to have recognition with this kind of camera and this kind of analysis. So we can increase in 1.3 megapixels, and we see that we're going to have a recognition for this guy at 12 meters. So it's more than necessary to have this kind of recognition, and we know that we're going to have a pattern which is going to be a monitoring observation, at even 21.6 meters. So it's very easy to select which camera we're going to use. We know that we don't have a focal length of 3.46, so we're going to use the 4, and we're going to see all the parameters changing, and here we're going to see what we're going to see from this person. Okay, so this person is going to be like this, more or less. We're going to see this in the license plate, but if we move the person more clear inside the field of view, we can see that we have the detection, and of course this is the license plate, and as we go closer we see how things are changing. So we can use this one in order to demonstrate to our clients what they're going to see exactly with the camera that we're going to use. So the site plan we're going to show why it's being used, and the 3D is, this is what we see. Usually we have two persons, one close, one far. From our field of view, you can see this more in the software if you wish. What I want to demonstrate in order to finish this short video is what else you can do with this kind of software. So with this kind of software, you can actually create a room that you might don't have, in order to demonstrate to the people how they're going to see with a camera inside a small room. So I'm going to create something like this now. These are brick walls. We have thick brick walls, we have curved walls, we have painted walls, thin walls. We can have a picture or a glass or a fence or a window or a door. So let's take a door and put it over here, and it's going to open to the opposite direction, let's say. So let's rotate this one, and let's close our room over here, which it's going to be set like this. So we have our camera over here. We check the camera and move it inside here, and we rotate the camera. And of course we see that the camera is not going to see outside the wall, and it's not going to see over here. And we look at the 3D room we have over here, our 3D representation, which is the presentation of the room. There are a lot of useful things over here, like the test chairs that we can use, like this one. We can put it over here and we can rotate it actually. And if you look over here, you can see the analysis. So let me select something else. You can see the analysis over here, and you can even move the camera in order to zoom to the specific area and see what exactly is over the analysis chart. So what else is very useful over here is that you can use a lot of things like different faces. You can use a tree or a bush or whatever. So let's try to put a tree inside the room. It's not very useful to have a tree inside the room, but I just want to demonstrate to you what is going on. And of course we can put something more useful inside the room, like a desk over here. And if you wish, you can move some furnitures inside, like chairs, inside the room, in order to show to someone how it's going to look like if it is inside an office. And of course you can put some useful things over the table if you wish, like money, and maybe a laptop. And you can of course use the 3D representation again in order to see what is going on over here. So I'm going to use my zoom, and I'm going to use my PTZ and my zoom and try to see what are this kind of money over this desk. So let's see if we can actually use this camera to see if we have 3 or 4 or whatever, or if they are blue or reddish or greenish or whatever. So I'm using the zoom now, and it's actually virtual PTZ mode, which we can use in order to see what is going on over here. So except this, of course, there are several things, several other other things. You see that I changed the camera in the zoom, and of course I changed the characteristics of the camera in order to see the specific area. So if you wish, outside the room, you might have something like what? You can have something like transport, like a car. So let me see if I can put a car over here. This one is something that I don't need. So let's put the car over here, as I said, which is going to be an SUV, and we put it here, and we rotate it a bit, and we take our camera, and we put it here, and we rotate the camera a bit, and we go to the 3D of view, and we can see the camera, and if we reduce the analysis, we're going to see where exactly this this car is based. So I'm going to demonstrate some of our projects. This one is from a big area in which the client needed to to have a condition in which we wanted to see who is stealing fuels from his area. It's a big area. It's a big area of in which actually we created a 3D demo. It's possible to take a schematic that the person has from the area and place your cameras on it. From here, as you can see, you can actually load the background, and when you load the background image, you can actually ask the software to give you the specific dimensions, and all of this is very real. So as you see here, this is the area in which the client wanted to know if someone is entering the place, and of course he wanted to see if he can distinguish someone. So we demonstrate to him that if he wanted to place the camera in this position, he would need a camera which he wanted to have only 1.2 megapixel, not wanted to give a lot of money. So it was very clear to him that he would have this kind of results in the far area, and of course he was convinced that he's not going to do his work with this kind of project. So we believe that this kind of software is really essential if you wish to actually demo. I'm going here to not to save the project, but I just want to see what is going on with the transport. For some reason, we have a problem with the software. Maybe, who knows? We have to clear this out and find out what is the problem. There are a lot of reviews of the software in almost every week. So some problems like this can be actually be controlled. So as I want to finish the software presentation, I just want to tell you that we can provide every kind of help for us concerning the software, because we're very we are working for a long time with this kind of software. We made the Greek presentation, and it seems that it's a software that help us out a lot in order to gain some projects from other competitors. So I believe strongly that for a person who is not very convenient with making calculations, it's going to give a lot of information as concerning the way that you can introduce your cameras and demonstrate to your client exactly what you need to demonstrate in order to convince him that what you're selling is going to provide him with help. So here you can see how it looks like the car inside inside a field of view. So there was some kind of problem or bug with my computer before. So anyway, concluding, I want to tell that, as I said, it's very easy to have all these kind of things with just one software. You don't need to know mathematics. You just need to understand what is a lens, what is the distance that you need to see, what is the maximum width in which you want to see, and most of the times these are going to be introduced by your client. I want to see 20 meters the width of a car because I want to watch the parking and I want to read the license plate. So you're going to have all this kind of information, and you don't need to know even the prototype, the European norma, because it's there inside the software. And all these kind of things are going to be introduced to you when you're using the bandwidth and the total hard disk space, as the percentage of movement more or less is going to be given. I know that the Hua or other companies have their calculators in order to more or less provide you some help. We have tried in the past to use most of these calculators, and we see that you're more or less very near if you use or know what are the percentages of movement or the percentages of timetable inside an area that you're interested in. So I strongly believe that it's a software that it's going to give you a lot of information on how to work with the camera and find very easily what kind of lens you need based on the distance from the scene and the width, even the height. And actually it's going to give you a good idea of what might be the tilt of the camera based on the height that you're going to install the camera, and it has a lot of analysis which you can of course change from here, like the custom resolution. So you can add all your cameras and you're going to have them over here. You can see that we have the default, and you're going to have all your cameras inside here, so you won't need to actually search for all this kind of data all the time whenever you have a specific project. So I strongly believe it's a software that help us get over the competition, and I strongly believe that it's a software that might help you to do that. Please be free to visit our website. You can translate it in English. It's www.gnems.gr, or send us an email or even call us. There are also the Skype contact, of course. And remember that you can go to the website, and this is the Greek one, by the way. So you can go to the English one and find all the information that you need inside, and we can provide you with some kind of discount if you go inside the specific area and you ask to buy this one. You can ask the person to have a small discount on the final price if you go there and ask, tell them that you were introduced to the software by our company. So thank you very much for your attention. I hope that I help you out with this kind of CCTV designing softwares, and I will be more than happy if I have some contact from you for any questions that might concern with this kind of presentation. Thank you very much for your time.